So we're going to be adapting our reverse Polish calculator to also be a converter from reverse Polish to infix notation. So for this we're going to be using inheritance and parametric polymorphism. So let's make an abstract class. So you cannot instantiate this class called expression. And this abstract class is going to have a couple of methods. There's going to be a method called value, which gives the value of the expression. So if you calculate this expression, and there's going to be a method called describe. And this we already implement. It's just a string, and it says the value of, and then is, and then the value to string. So this definition describe is inherited by the subclasses, while this value has to be specified in the subclass. Alright, let's make a immutable class, a case class for a constant, so meaning a number. And then it says, well, you have to implement some of these methods. Okay? The value is just a constant. Okay, and I will also override the toString, and then I just say n.toString. Similarly, I can also have a case class for an operator. This is the operator name. Let's put it in between the left hand side, which is an expression. The left hand side is an expression, and the right hand side is also an expression. And this also extends expression. So what is the value of this thing? Well, let's get this operator by name method and put it in here. So we need the operator by name of the operator name, and then the left hand side. We also need the value of the left hand side, so this recursively calls value on the left and right subtrees, and then also the value. So imagine we have an expression tree, right? So where each of these, this is an internal node, and these are the leaves. Then we can calculate it like this. It should be operator by name, not operator name. And I also want to override the toString. No, not this one. And I want to say that the left hand side toString, and maybe also put some parentheses in between. And say the left hand side plus toString plus the operator name and the right hand side toString, and then end with a parenthesis closed. All right. So I hope you can imagine that if you have a sort of tree of these things where these are the internal nodes and these are the leaves, that if you call toString, then this will print the actual expression. Also, this will give you the value of the expression. All right, so now we're going to be adapting our code such that instead of actually just calculating our expression, the value of some expression in reverse Polish notation, it just produces an expression. So of course, in this expression we can call the value, which would give us the same thing as before, but we can also print it, which we couldn't do before. So printing it meaning in infix notation. All right, so this should now return an expression. Also, the stack will now also contain expressions. All right. right? So imagine this, like in the video, that you're sort of making this expression. So every time we get an operator, we have already two expressions on the stack. So what we can do is we make a new expression, a new operator, where we have the left-hand side, which is an expression, and the operator name, which is the element, and the right-hand side. So this will construct a object, and the left and right-hand side of the arguments, which are also expressions we got from this stack, because the stack is now a stack of expressions. All right, and if the input is a number, we say it's a new constant. We don't have to say this new because they're case classes. Constant L.toInt. This we're pushing. So that's all there is to it. So now, instead of actually just calculating the result, it's actually building a tree. The tree like in the video I just showed you by computer file. So in there, in this tree, the internal nodes are these operator things, and the other ones are constants. And notice that if we start using this now, then we can also get, what is this? Nothing interesting. Okay. Let's say reverse Polish dot calculate. Well, it's actually, let's refactor this to be reverse Polish to expression or something. I like it. Let's do that. Its name is a bit long, but its scope is also very long, right? So maybe it's actually a bit redundant because the class's object is already called reverse Polish. So now reverse Polish dot reverse Polish to expression is maybe a bit redundant. So in this case, I think you could have also said RPN to expression, because it's clear that it's about reverse Polish because it's already in the reverse Polish object. Anyway, let's take a little example. This will give us a expression, and this is the toString. Why does it print constant? Oh, I overridden describe. I did not override the toString. Okay. Let's try this again. Good. So similarly, you can also just call describe on this and make a very complicated expression. Let's say so now you see it prints it in infix. All right, and this describe method we inherited from the abstract base class, and for this value method we use dynamic dispatch to determine which code is going to run. So every time you get here this value or this toString, let's see, this value, so which code is going to be run then depends on the object that is represented in this left hand side or this right hand side. Okay, so that's it.